Hi everyone, so today's problem of the day is earliest finish time for land and water rides 1. So what is given in description? You are given two categories of theme park attractions, land rides and water rides. For land rides, land start time is factor is given, and for that the height index is the earliest time for the height land ride can be boarded, and land duration I is the how long the height land rides ride last. And for the water ride, water start time J is the earliest time the jth water ride can be boarded, and water duration J is the how long the jth water ride lasts. A tourist must experience exactly one ride from each category in either order. Uh, a ride may be started at its opening time or may later moment. If a ride is started at a time t, it finishes at time t plus duration. Immediately after finishing one ride, a tourist may board the other if it is already open or wait until it opens. So we will be giving two vectors, land start time and land duration for the land ride, and for the water ride we will be giving water start time and the water duration. So a person need to complete one land ride and one water ride, and we need to find the earliest possible time to finish. But it is earliest possible time to finish. But if you will see, we can start from the start time, and we can the ride should last for that duration time. So if we will see for this example one, suppose I have started my land ride, we need to complete one land and one water. So we have two land rides, so we need to select one from these two. Suppose I have selected this two. So if I started at two, and it will the duration will be 4, so it will last till 6 times 6. And since this water start time is 6 only, so we can from 6 we can start the water ride from 6. The duration is 3, so it can be completed in 9. So in this case the time is 9. Suppose we have done some other, suppose instead of this I have started with this 8. So if I will start with 8 to 8, duration is 1, so it will take 9 here. And it will start from 6, it is already 9, so we can start this, and the duration is 3. So in this case, that our time will be 12. The minimum possible is 9. One more case can happen. We can start the water ride first. If we will start the water ride first, then start time is 6 and the duration is 3 to 6 plus 3, which is 9. And we can select suppose the duration of this is less, so we can start this. So again 9 plus 1, 10. For this case the earliest possible time to finish is 10. So minimum possible in our case is 9, so we can return 9. If we will check for the second example, there is only one land ride and one water ride. So we don't need to select which land ride and which water ride we need to select first, but we need to select first. We need to done what, land ride or water ride. Suppose I have done land ride at the first, so the 5 plus 3, because it will start at 5 and the duration is 3. So till time 8 it will finish, and then the water ride it will start at 1. One is it is greater, so we can start it. The duration is 10, so it will take 18, but the time is 18. But if we will start this water right first, then what will be the case? 1 plus 10, so it will be 11. And since 11 is already more than 5, so we can start the land right. And 11 plus 3, so it will be 14. 14 and 18, the smaller is 14, so we can return 14. So we will see for the constraint. Constraint is n and m can range from 1 to 100, and this n is the size of the land vector and vectors, and m is the size of the water vectors, and the value can range till 1000. So constraints are small only, so we can try using a brute force approach. So if we will see what we can think of doing. There are so many scenarios possible. First is like which we need to do the first. फर्स्ट अपन को क्या करना है, लाइक वी नीड टू डू द लैंड और वी नीड टू डू द वाटर. So two possible cases are possible. If we need to do land first, then what we can do, we can find the minimum possible time to finish the any one land ride. If we are doing water first, we need to find the minimum time to finish the water ride first. If we will get the minimum time for first one, then easily with the help of that minimum time, we can find, suppose I got the minimum time to finish my land ride, then easily with the help of that first time I can loop through this water time and I can try to calculate my minimum possible answer. Yeah. The same thing I have done in my solution. I initialized, I'm doing for these two cases. First cases is like I'm starting the land right first and then water. For my second case, I am starting the water right first and then the land right. And initially, I initialize the answer equals to int max because we need to find the minimum possible answer. So we will update our answer using this function, and then we can return our answer. So now, if we will see the solution, what I have done in my solution, fs is my first ride start time, first ride duration, second ride start time, and second ride duration. So first, if I am finding the minimum possible time to complete my first ride, suppose I am for my first ride I'm doing for the land, and for first ride my for the second condition my first ride is water. So if suppose my first ride is land, so we will try to find the minimum possible answer for the land. The minimum is at the starting is int max, and then we'll be updating our minimum equals to minimum comma start time plus duration. So start time plus duration will give us the minimum possible value for the our first ride. If our first ride we got the minimum possible value, then what we can do, we can go switch to the second ride, and we can with the help of this minimum and this duration, we can find the earliest possible time. So what we can do, so we will this minimum or the second ride start time, we will do the maximum and then we will add into a duration. Why we are doing this maximum? Suppose my minimum value for the first time to complete is 8 and my starting time for the second ride is 3. So in this case, if my completion is 8 and start time is 3, so I need to make this maximum only because I'm completing this first. So after this only I can take this. So I will take this 8 in this case. But if suppose my first ride is completing at 1 time and my second is starting at 8, then I can't start the second ride before 8 because this is the starting time. That's why I'm taking the maximum of this minimum ride time and the starting second ride starting time, and I'm adding the second ride duration, and this way I can calculate the minimum possible answer, and at the end I can return my answer. I hope you understood this question. If we will see the time complexity will be big of maximum of n into n comma n, and space complexity will be big of 1 because we are not using extra spaces. Maximum of n comma n, why? Because we are using m plus n, because in both cases we are using one loop for n and one loop for m. Yeah, time obviously will be big of maximum of m plus n. So yeah, thank you.